Hi there. So I'm going to talk about section 7.1 because we're going to begin chapter 7. Chapter 7 is on probability, so this is where we're actually going to formally define the term. Loosely put, when you talk about the probability of a various outcome, you're talking about the likelihood. I believe you're all familiar with that term. It's used a fair amount in society. But we will actually formalize it in the next, not this section, but the next one. All right, so in this section 7.1, there's actually just a lot of definitions here. There aren't a whole lot of new ideas. However, I like to define various terms because I want to be sure that we're all speaking the same language when we discuss them. So 7.1, I'm going to start out by writing a lot because there's just one long definition. All right, I'll underline all words that I'm defining. So, an experiment is an activity with an observable result. Each repetition is called a trial, and the possible results are called outcomes. All right, the set of all possible outcomes is called the sample space. That's a really important term. When we're dealing with various experiments and we talk about the sample space, in the context of that particular example, the sample space essentially becomes our universe. All right, a subset of the sample space is called an event. All right, so those are the main terms that we're going to discuss. So what's some examples of experiments? Well, one of the things that I'm going to be mentioning here is when we talk about flipping coins or we talk about rolling a die, we're always assuming that the coins are fair. In other words, it's equally likely that the coin will land on heads or tails. Similarly, when we talk about a standard six-sided die, we're assuming that it's a fair die. In other words, that it's equally likely to land on any of the particular sides. In practice, these things are hardly fair because they're not weighted perfectly. All right, so let's talk about an experiment, how about of rolling a fair die. Okay, well, notice that the set of all possible outcomes is called the sample space. So, very often what we're going to want to do is say, all right, what is our sample space? Thing to note is it's a set, and therefore we have to write it in set notation. So, usually we call our sample spaces S. And what are all of our possible outcomes rolling a fair six-sided die? Well, we could get a 1, 2, 3, 4, 5, or 6. All right, so why don't we now talk about various events? Well, we could talk about the event of rolling an even number. I'll call that E. Now remember, all of the members of various events, they all come out of our sample space. So at this point, this is our universe, okay? So I think you'll grant me the event of rolling an even number consists of 2, 4, and 6. All right, I could talk about the event of rolling a number, say, greater than 9 I'll call that N. All right, so what numbers in here are greater than 9? I think you'll grant me it's the empty set, okay? And when you have an event that is equal to the empty set, it's called an impossible event. Okay, we could talk about the event of rolling a number less than 9. I'll call that L. And if you look at our sample space, I think you'll grant me we get the whole thing. When the event is actually equal to your sample space, it's called a certain event. Okay, so that's an example of one particular experiment. Another experiment we could talk about is, how about flipping 2 coins? Actually, let's do flipping 3 coins. Okay? So suppose we toss 3 coins. What I want to do is I want to write out my sample space. Okay, I like to do these in a very organized fashion because otherwise I'll forget things. So I'm going to start out by saying, okay, well, one possibility is we could have 3 heads. Okay? Now, a next possibility is let's write out all possible ways we could get 2 heads. Okay, well, I could have a head, and a tail. I could have a head, a tail, and a head. Or I could have a tail, head, head. All right, so I've done 3 heads, 2 heads. Now I'll do 1 head. Think you'll grant me we have HTT, THT, or TTH. And then our last possibility is where we have no heads, in other words, all 3 tails. So there's a sample space, okay? We could write out the event of, how about rolling at least 2 tails. Now, what does at least 2 tails mean? Well, at least 2 means 2 or more. And since we're only tossing 3 coins, in the context of this problem, it means 2 tails or 3 tails. So, doesn't really matter what we call this, we'll call it R. So what we need to do is look in our sample space and write all possible outcomes that have 2 tails or 3 tails. And it's kind of nice, it's our bottom row, so we don't have to look too hard. And there's that event. Okay, so those are a couple of examples. Why don't I go through one more here. Okay, so how about with this example, let's take the scenario that a student takes a 3-question true-false quiz in which he guesses the answer or the answers to all 3 questions. Now the reason why I have that is because then that means he is equally likely to be correct or wrong. Equally likely outcomes are extremely important. Okay, well, what I want us to do is give the sample space. And again, I'm going to write this in somewhat of an organized fashion so that I don't forget anything. Well, let's talk about the best possible scenario. How about that he's correct on all 3? Okay, the next best scenario is where he's correct on 2 of the 3. So we could have CCW, CWC, or WCC. Notice this is very similar to the previous. All right, so our next scenario is where he's correct on only one of them. So he could be correct on the first, correct on the second, or correct on the third. And then we have the last situation, in which case he's wrong on all three. So when you're writing out sample spaces, you want to try to keep them in an organized manner. Okay, so I just want to define one more term, and I will use this scenario in which to do that. Let's give the event where he's correct on all three. I know this is not a very interesting situation, and we'll just call this event E. And I think you'd agree that it contains just one possible scenario. Now let's give the event where he's wrong on all three. We'll call that B. And there we go. Now, these are both sets, okay? I claim that they're disjoint sets. Remember, disjoint sets are sets that have no elements in common, or where you would say that the intersection is equal to the empty set. Recall, that's our term for disjoint sets. When we're talking about events, another way we could put it is we could say that E and B are what we call mutually exclusive. And two events are mutually exclusive if they cannot occur at the same time. So for example, you can't be correct on all of them and wrong on all of them at the same time. Another example, going back to our rolling a die, is that you can't roll an even number and an odd number at the same time. So those two events would also be mutually exclusive. All right, that is all that's in section 7.1. Thank you.